Hi, this is Misty, and today I'm going to do an experiment about static electricity. So, static electricity you often find when you are wearing socks and you go against a carpet and then all of a sudden you touch like a doorknob and you get shocked. That's static electricity. Well, we can also see static electricity on a balloon. And we're going to be learning all about electricity and static electricity in science now. So what we're going to do is we're going to see if different materials will make more static electricity on this balloon. And the way we'll know is because it'll pick up more pieces of this little confetti that will stick to the balloon. So first I'm going to show you the control, which is without rubbing anything. So I put it down to the confetti, and you'll see no confetti sticks because I haven't had any static electricity. But now I'm going to take a piece of cotton, which is like what your socks are made out of and a lot of your clothes, and I'm going to rub that on the balloon for, I don't know, maybe 15-20 seconds. And now I'm going to put it up to the confetti and see how much confetti I got. So I'm going to take off the confetti and count it, because that'll tell me how many pieces stuck to it. And I got 23 pieces of confetti stuck to the balloon when I rubbed the cotton. So I'm just going to write that down so I remember that it was 23. So I had none for the control, and now I have 23 for the cotton. Now I'm going to take a piece of paper towel, and I'm going to use that and rub the balloon. I'm going to pick a different spot on the balloon, and I'm going to start rubbing it for the same amount of time, like 15 seconds. And we're going to see how much static electricity the paper towel will make on the balloon and will build up on the balloon. So I'm going to put the balloon to the confetti and see. And if you look, I have a little bit of confetti stuck to it. So I'm going to count that confetti as I'm pulling it off. And I see that there are 10 pieces of confetti on the balloon when I use the paper towel. So I'm going to write that down so I'll remember it. Now, before I do another thing, I'm going to put my balloon onto my computer because it's metal, and that'll discharge any static electricity that was left. So I'm going to take my next material, which is acrylic, and I'm going to rub that onto the balloon and see how acrylic does. Acrylic is a cloth that sometimes is in like your bathing suit or some stretchier clothes. A lot of times have some acrylic in it. It's actually kind of a plasticky material. So rub that for the same length of time. And now I put it up to the confetti, and you see, oh, I didn't get very many. I only got 5 pieces of confetti that time. So I'll pull those off, and then I'll write down 5 for acrylic. That way I remember how many I got. All right, so I'm going to discharge the static electricity again by tapping it on my computer, and I'm going to check it and make sure all the static electricity is gone. But I see, oh, there's still a little static electricity on it. So I'm going to wipe it again on the metal. So I'll discharge all of it and check it and see. And I see, yep, it's good. So now I'm going to take my last material, which is wool. And wool is that kind of itchier material that you often have in sweaters or scarves or hats, and sometimes it's itchy. So I'm going to use that, and I'm going to rub it on the balloon for the same amount of time as I did my other materials, and we'll see how much static electricity is made by the wool. As you can see already, the little pieces of the wool are kind of sticking to the balloon. So now I put it in, And you can see I have quite a bit of confetti on this balloon. So I'm going to pull it off and count it. And this time I got 21 pieces of confetti. So I'm going to write that down so I remember it. So now let's think about it. I had wool, in which I got 21 pieces. I had acrylic, in which I got 5 pieces of confetti stuck. The paper towel had 10 pieces. And the cotton had 23. So which materials made the best or the most static electricity? And it was the wool and the cotton. Those two made the most static electricity on the balloon. So I know that those two materials can produce more static electricity than the other materials, which is why when you are wearing socks and you go on a carpet, you produce a lot of static electricity and can shock people. So now that we did our experiment, we're going to look at page 58 in our Be a Scientist notebook. And we're going to record what we saw with the balloons. So for sample A, or the control, we got 0 confetti. And for the cotton, we got 23. Paper towel, we had 10. The acrylic, we had 5. And the wool, we had 21. Now, they want us to circle the sample that had the largest and to underline the sample that had the smallest. So I'm going to circle the 2 that had the most because they were very similar, which is the cotton and the wool. And I'm going to underline this acrylic and the paper towel because they had the least amount. And so now let's look at what it says. It says to describe the sample that had the largest change. So we can say the largest change was when the balloon was rubbed by the wool or the cotton. I know because when I rubbed those two materials, the balloon picked up the most confetti. So that was the biggest change in the balloon. Because if we looked at our observations, cotton and wool had the most confetti, acrylic and paper towel had the least confetti. Although in our control, we had none because we hadn't rubbed anything. There was no change at all. All right, so now we're going to watch a short video about static electricity.
Hi, Malik here. Have you ever reached for a doorknob and zap, got a shock? Why does this happen? That shock is caused by static electricity. Have you ever come inside on a cold day, taken off your hat, and had your hair stand straight up? That's static electricity. Have you ever rubbed a balloon on your sweater and held it near a wall? What happened? That's right, the balloon stuck to the wall. This is also caused by static electricity. Static electricity is why some clothes stick together when you pull them out of the dryer. Can you think of other times you've seen or felt static electricity?
All right, so it asks what example of static electricity was shown in the video, and what effects did the static electricity have on the object. So what are some examples of the static electricity that was shown in the video? I saw the socks rubbing on the carpet, and then you touch the doorknob, socks rubbing on the carpet, and then you touch another person. The balloon being rubbed on a sweater and then sticking to the wall. When you took your hat off of your head when you'd been outside and your hair sticks up, that's static electricity. So those are the ones that I saw. I might have missed one. If I did, you'll have to let me know. And what are some other things that would be static electricity? Think of some other things that you might have. Oh yeah, maybe when the clothes stuck to each other. I forgot that one was in there. So what effect did the static electricity have on the object? So think about it. What happened to the girl when she was walking with her socks and then touched the doorknob? It shocked her. What happened when they rubbed the balloon onto his sweater and he put it up to the wall? It stuck. So static electricity is going to affect the different objects. All right, so now we're going to read pages 254 and 255 in the science handbook and think about what causes electricity and to draw and label a diagram that shows the different combinations of electrical charges and how they interact with each other. So let's see what causes electricity. So these are the 2 pages we're going to read. Electricity and magnetism. We're going to look at electrical energy, so electric charge, and we already read about static electricity, so we'll talk about that a little bit too. So electrical energy. Matter is made up of tiny parts called particles. These particles either have a positive or a negative charge. Electrical energy is the energy of these charged particles. You can think of everything as either having a positive or a negative. And you sometimes feel a shock when you touch a metal doorknob. This shock occurs because of electricity. If the room is dark, you can see a quick spark of light with the shock. A flash of lightning and the glow of a light bulb also occur because of electricity. So if you're ever in a really dark room, you can try this, which is you can take and rub like your socks against a carpet and then touch a doorknob and see if you can see it. It's got to be really dark. So it says the property of matter that causes electricity is an electrical charge. You cannot see electrical charge, but you can understand how objects with different charges interact. There are 2 types of electric charges. One is called positive, the other is called negative. The diagram shows how objects with positive and negative charges affect each other. So an object with a positive charge pulls on an object with a negative charge. That's what happened when the balloon stuck to the wall. What you did is you built up negative charges onto the balloon when we rubbed something. And it's also what happened with the confetti. So when we rubbed something on the balloon, we made negative charges. And depending on the material, there was more negative charges or less negative charges. And so when we rubbed it, we made all these negative charges, and the wall or the confetti have all positive charges. So what happens when they get near each other is they stick. So that's what happened with the balloon that we saw and when he rubbed the balloon in the video. Objects that both have a positive charge push away from each other. And then objects that both have a negative charge also push away from each other, which is important to know because what happens is when we build up static electricity, we build up those negative particles because most things just have their balance. They have the same number of positives and the same number of negatives. But when you make static electricity, you build up all those negative charges. You build them up on the object. And when when they touch something, they have more negatives, and that's when they're going to stick to something. But what happens when there's too much negatives? So all these negatives have built up because of static electricity, but there's nothing to stick to. If there's too many, remember it said that negative, when they're touching other negatives, want to push apart. And so that's when you have what's called discharge, and when the static electricity discharges. And what happens is when you touch the doorknob, the static electricity discharges because all those negatives want to go away because they don't want to be there. And what happens is it discharges, and when static electricity discharges, it discharges as light and heat, which is what is lightning. Lightning is just a whole bunch of static electricity in a cloud. So all the static electricity builds up in this cloud, all these negative particles. And when there gets to be way too many of them, it has to discharge because nothing wants a lot of them. Everything wants to be balanced. And so it discharges it, and it discharges it in the form of light and heat, which is lightning or a shock. A shock is light and heat, but we feel it kind of as an ow. Okay, so let's look at our pages. What causes electricity? So electricity is caused by a buildup of negative particles. And then our next question that had to go with our reading has to do with draw and label a diagram that shows a different combination of electric charges and how they interact with each other. The first drawing was the one with the negative particle and the positive particle. And we know that when the negative and a positive are near each other, that they actually stick to each other. So they go towards each other and they get stuck, just like what happened with the balloon. When you have a positive and a positive together, then they don't like each other. They push apart. And then the last one is if there's a negative and a negative together, they also don't like each other and they do the same thing as a positive and positive, and they also push apart. Those are the three different combinations of electrical charges: a negative and a positive, a negative and a negative, and a positive and a positive. Remember, you want negative and positive if you want something to stick. So this is my challenge to you. Get a balloon and rub it against different materials, maybe your shirt, maybe your head. See what works best and try and get it to stick to the wall.